Question 13. A particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given by this function. It says, what is the acceleration of the particle at time t equals 2? Now, again, this is in the calculator section, which means we get to use our calculator. Anytime answer choices look like this, it should be pretty obvious that you get to use your calculator. And so essentially you're going to graph this function, but let's first understand what it's even asking us to do. We're given the velocity function and they want to know what the acceleration function or the acceleration is at a specific time at t equals 2. This, you may or may not realize, but is like the holy grail of problems because it's such an easy problem, like super easy, but only if you know how to use your calculator and only if you understand the concept of how acceleration relates to velocity. So hopefully you remember that position is the original function, velocity is the first derivative, acceleration is the second derivative. So acceleration is essentially the derivative of velocity, which you might be thinking in your head, oh no, I have to take the derivative of this function and then I have to plug in 2. You could do it that way, and honestly you would probably get the right answer, and you can use your calculator to do it that way. And you can use the product rule here, and you can use the chain rule, and you can have as much fun as you want doing that. But there is so much of an easier way, and I definitely want you guys to use your calculators in order to do this. So, the bad thing is that you have to use a graphing calculator. Desmos does not have this feature. So if you're working on Desmos, you'd actually probably have to do this the long way. But because I want you guys getting trained with the graphing calculator, I'm going to teach you how to do it with it so that when you take the benchmark on Thursday, you know how to do it. So, v of t equals t cubed e to the t plus 1. Plug that into your calculator for y1, and we're going to graph it, and I want to graph it on a nice viewing window. So in order to graph it on a nice viewing window, here's the viewing window that I looked at when I was graphing it. I looked at it on a viewing window from 0 to 2.5 because they told me that it was greater than 0, and they said that we're evaluating it at 2, so I figured 2.5 would be a little bit more than 2. I looked at it from 0 to 100 because I wanted to get a nice picture of what it looked like. And so when I first graphed it, it didn't look very nice. So I wanted to get a nice picture of what it looked like, and from 0 to 100 was a semi-decent picture of what it looked like, in fact. Now, this might not mean much to you. This is just the velocity function graphed. But in order to find the acceleration, all we have to do is find the derivative of this function at a specific value. They want to know the acceleration at 2. So if I can find the derivative of this at 2, I will have found the acceleration at 2. You want to know how easy it is? Here's how easy it is. See this button right here that says calc? Alright, we go in there all the time to find zeros and maxes and mins and stuff like that. So go to there. So second calc, which takes you to this menu right here. Alright, so second calc takes you to this menu. We've used a lot of these. We've used 0, we've used maximum, minimum, intersect a little bit. This is the one we're going to use right now. So remember that dy dx, the sixth function down, dy dx is the derivative. So if you scroll down, or if you actually click 6, it'll take you to the derivative. So push 6 and it'll take you to the derivative. And it's just going to bring up like a blinking light or a blinking star, and it'll probably just give you a value to begin with. So for example, mine was just kind of focused on this value here, which I really don't care about this value here, but it's telling me the derivative of this value is 18.530, whatever. Alright, I don't care. I care about what the derivative is at 2. So I'm actually just going to type in the number 2. So on your calculator as well, you guys can just type in the number 2. And you should have x equals 2, and then push enter. And if you push enter, it will calculate for you what the derivative of the velocity function, because remember this is the velocity function, it will calculate the derivative of the velocity function at 2, and it tells you that dy dx, the derivative of the velocity function at 2, is 401.711. And again, how easy is that to make your calculator find the answer for you? That is super easy. So literally, this is the answer, 401.711. You don't have to write anything down. All you need to understand is that the acceleration function is the derivative of the velocity function. So to evaluate at 2, I just find the derivative of this function at 2. And your calculator can do that for you super quick. So definitely get practice with that, because that is supposed to be a super easy question, but it doesn't look easy until you understand what it's asking exactly.